The world of saws is made up of many marvelous tools. Big saws and jigsaws, hand saws and band saws, bag saws and hacksaws. They all have their specific purpose. Hacksaws are chiefly for cutting metal or other tough materials. So what keeps hacksaws on the cutting edge? Hacksaws come in many shapes and sizes. Companies make hacksaw blades out of a wide range of steel alloys. Here, a thin band of steel feeds into a machine that cuts it into blanks 25 to 30 centimeters long and 1.3 centimeters high. Workers load 300 blanks at a time into a jig. They lightly hammer them to compress them into a block for easier cutting. They then feed the block into a machine called a mill grinder. It cuts teeth into the upper side of the blanks. A water-based lubricant washes away the metal particles. This hacksaw model has a 24-point blade, which means there are 24 teeth to every inch or 2.5 centimeters. Workers use an ordinary paintbrush to remove any metal residue. The quality control department inspects each blade for flaws. Then it's off to the next phase. A separator detaches each of the 300 blades, aligns them, then sends them through a setting machine. The machine bends the teeth to either side at a slight angle. This is called offsetting. It'll enable the blade to clear away particles as it saws, preventing it from jamming. Now it's time to harden the teeth. The factory does this by heat treating the metal. A worm gear aligns the blades to enter a heating coil. In this process, the electromagnetic heating coil heats the teeth to temperatures as high as 1200 degrees Celsius, depending on the type of metal. This takes no more than 2 seconds. After the blades exit the heating coil, the surrounding air cools them down over the next several hours. This phase is called air quenching. The blades are now ready for printing. An offset printing press applies ink to raised lettering on a cylinder. That cylinder transfers the ink to strips mounted on another cylinder. These strips then print the company name, the blade length, and the number of teeth per inch on the side of the blades. Now a machine inserts the blades in groups of 5 into slots called fingers. The fingers rotate the blades and place them on a conveyor belt. The machine raises the blades and tapes them together at one end. This makes it easier to transport them to another part of the factory, where production continues. Next, the hacksaw's frame, the component that holds the blade. Workers place the frame components in a jig that's positioned on a rotating carousel. A robotic welder fuses the components. A press punches 3 holes in the handle for attaching a foam or plastic grip. Workers fit the 2 halves of the grip in a sonic welder that fuses them using high-frequency sound waves. The sound waves create friction at the seam. This generates enough heat to melt the parts together. Now the frame is ready for the blade. An automatic device tightens a wing nut to put tension on the blade. A final quality control check. With each randomly selected blade, the testing machine cuts through a block of stainless steel. The machine performs this test 6 times per blade. Then the computer calculates the average number of strokes. If that average falls within the norms for this particular model, the batch gets the thumbs up. keeping those thumbs, of course, clear of these sharp tools. Invented thousands of years ago, the handsaw continues to make the cut. You'll find it at every building site, always at the ready. Power tools are higher tech, but the handsaw has a basic appeal. It doesn't need an extension cord and almost never breaks down. It's a trusty tool with the teeth for the job. Handsaws come in many sizes. To make them, a machine uncoils steel and draws it into a mechanized punch. The punch works at a blurring speed to cut teeth in the steel, 140 notches per minute. Here it is in slow motion. It makes 2 cuts for each sawtooth. A reel takes up the newly serrated steel and then will feed it back to cut teeth on the other side. Next, a finger-like device unrolls the steel and pushes it to automated jaws. The jaws bend the teeth, alternating the direction of each one. Here's a slow-motion look. This is called setting the teeth, and it will allow the handsaw to operate smoothly. Now a die punch cuts the steel coil into pieces called double blanks. Double because 2 saw blades will be made from them. The die also makes holes in one end of the double blank for attaching handles. They feed the double blanks to a shear machine. A long blade descends and cuts it in half on the diagonal, making 2 saw blades. Finally, they press the saw blades up against a sand belt to smooth out the edges. This is called deburring. Here they're making a higher-end saw blade. They flush a piece of steel with coolant as a machine plunge grinds it to make teeth. This method is more time-consuming, but results in a superior tool. Again, they set the teeth. But this time, mechanical jaws do the job, a blade at a time, rather than working on one long coil of steel. The saw teeth will need to be strengthened in order to perform. So rollers move the blades to an electrical coil. Within milliseconds, the temperature of the blade shoots up to almost 900 degrees Celsius. This tempers the steel. The blades drop off the conveyor into a bin. Here's a look at a blade before heat treating, and this is after. The black burn line is a sign this saw can take the pressure. A conveyor wheel dunks them in a pool of clear protectant. This will keep them looking shiny. When they're dry, the blades undergo a trademark technique. They place one on a table. It rises, and a squeegee silk screens the company name onto it. At this point, the ink is still wet. They spend 30 seconds in an infrared oven, enough time to bake on the brand name. They slide cardboard sleeves over the blades. And now it's time to get a grip. A worker fits 2 plastic handle parts together and places them on a carousel. An ultrasonic sealer moves in. It emits a high-frequency sound, and the vibrations melt the 2 plastic pieces together, forming a handle. A worker fits the handle onto a blade, and a machine rivets it in place. Some saws have wooden handles. Because riveting could split the wood, they bolt it on with screws and riv nuts. And now, you have tools that are cut out for the job.